basic sine function is y equals sine x, and the basic cosine function is y equals cosine x. On the screen are the formulas for graphing these functions. A stands for the amplitude, which is the height of the graph. Amplitude is always positive. B is their frequency, which is the number of cycles in 2 pi. H is the phase shift, which is a horizontal shift, and K is the vertical shift. Note that sometimes a function will appear in the form y equals a sine or cosine times bx minus bh plus k, in which case you will have to factor out the b from the parentheses.
How to graph the basic sine function. To start, plot your first point at the origin, 0, 0. The amplitude is 1, so the highest and lowest points on the graph are 1 and -1 respectively. The frequency is 1, so there is 1 cycle in 360 degrees. To find the period, plug in 2 pi over b. For this graph, the period is 2 pi over 1, which is 2 pi. To find how to increment your x-axis, plug in period over 4. For this graph, 2 pi over 4 equals pi over 2. Now label your axes. The y-axis is incremented according to the amplitude, and the x-axis according to the period over 4 in radians. Plot your points accordingly, and then connect the dots with a curved line.
How to graph the basic cosine function. Start at the amplitude, 0, 1. Then repeat the same steps for frequency, period, and period over 4 as you would for graphing sine. Plot your points accordingly. Now, time to play connect the dots.
To graph negative sine and negative cosine, all you have to do is negate the y values. The new graphs will be reflected over the x-axis.
Now we will learn how to graph several transformed sine and cosine graphs. To read these graphs, note that anything in blue is the basic function, black is the function with just the amplitude changed, and magenta is the final function. If the amplitude is greater than 1, the graph becomes a times as tall. If there is a vertical shift, the graph will be moved k units up or down. To do this, add or subtract k to each y coordinate. Plus k means up, and minus k means down.
To read these graphs, black is the basic function, blue is the function with the changed frequency, and purple is the final function. If there is a horizontal shift, the graph will be h units left or right. To do this, add or subtract h to each x coordinate. Minus h moves the graph to the right, plus h moves the graph to the left. To find the period, use the equation 2 pi over b. Remember, you might need to factor out the b from the given function. To increment your graph, use the equation period over 4.
The domain of tangent is all real numbers except for odd multiples of pi over 2, since cosine x equals 0 at odd multiples of pi over 2, making sine x over cosine x undefined. The range is all real numbers. Tangent is an odd function and is symmetric with respect to the origin. The period of tangent is pi over b. The x-intercepts are at all multiples of pi. Vertical asymptotes are at odd multiples of pi over 2.
How to graph a basic tangent function. Start by incrementing your x-axis by pi over 4 and incrementing your y-axis according to the amplitude. Plot your first point at the origin, 0, 0. Draw vertical asymptotes at x coordinates negative pi over 2 and pi over 2. The negative amplitude is at negative pi over 4 and negative 1, and the positive amplitude is at pi over 4 and 1. Draw a curved line through the points.
The domain of cotangent is all real numbers except for multiples of pi, since sine x equals 0 at multiples of pi, making cosine x over sine x undefined. The range is all real numbers. Cotangent is odd and is symmetric with respect to the origin. Period is pi over b. The x-intercepts are at all multiples of pi over 2. Vertical asymptotes are at multiples of pi.
How to graph the basic cotangent function. Start by incrementing your x-axis by pi over 4 and incrementing your y-axis according to the amplitude. Plot your first point at pi over 2, 0. Draw vertical asymptotes on the y-axis and where x equals pi. The negative amplitude is at 3 pi over 4, negative 1, and the positive amplitude is at pi over 4, 1. Draw a curved line through the points.
We will now graph transformed tangent and cotangent graphs. If the amplitude is greater than 1, the graph is vertically stretched by a factor of a. If there is a vertical shift, the graph will be k units up or down. To do this, add or subtract k to each y coordinate. To find the period, use the equation pi over b. To increment your graph, use your newfound period using the equation period over 4.